Hi there, Science 10s. So today I want to talk a little bit about molecular compounds. So you've already seen a video, a YouTube video by science teacher Tyler DeWitt, who just did an awesome job on how to name molecular compounds. And he also talked a little bit about the properties of molecular compounds. So he talked about that these are all non-metal. So to the right of the staircase on the periodic table. And the thing that is different from ionic compounds is that there's no metal anymore in them. So remember, metals are on the left side of the periodic table. And molecular compounds, he also called them covalent compounds. That's another name for molecular compounds. Well, they're called that because they have covalent bonds where they're sharing electrons. Okay, so just a reminder, on your periodic table, these are the guys here that we're talking about, right? Non-metals are all found to this side of the periodic table. Remember that the ionic compounds, when we did ionic naming, they all had a metal like lithium or maybe a multivalent like iron. Okay, but all of these molecular compounds are now going to be formed from non-metal plus non-metal. So they get their own special way of naming because they are different than the ionic compounds. Okay, so looking at our notes, again, he went through a really good job of talking about sharing electrons and the difference between an ionic compound, a transfer of electrons. And one thing that I wanted to touch on was that many of the molecular elements are what we call diatomic or polyatomic. And I meant to say here diatomic, or this word should say or polyatomic. So these are ones that you're going to have to memorize. And it doesn't say it on your periodic table, and that's why you have to learn it off by heart. And so there's one saying that people may use to help memorize the diatomic elements. And they say, I have no bright or clever friends. So what elements are they talking about? Well, I for iodine, and it's I2, and it is a solid. Hydrogen, H2, and that is a gas. What is the N for? Well, it is N2, and it is a gas as well. What is bright? Well, Br2, and that guy is a liquid. He's the only liquid nonmetal. O for O2, gas. Clever for chlorine, Cl2, gas. And F fluorine, and that is F2 gas. So you have to memorize these diatomic elements. And then there's a few polyatomics. Remember, diatomic means there's two atoms that make up a molecule. With a polyatomic, you've seen this word before, it means there's more than one. And so we see these polyatomics, O3, ozone gas. There's 3 oxygen atoms that are covalently bonded together. They're sharing electrons. P4, which is a solid, and S8 is a solid. So if you were to write sulfur, if I asked you what is the formula for sulfur, and you wrote just S solid, that is not correct. You wouldn't be able to get a mark for that. It is a polyatomic. So you have to memorize these diatomic and polyatomic. So if you don't want to memorize the little saying, I have no bright or clever friends, there's another way you can do it as well. And that's by looking on your periodic table. And I think of this as the hockey stick and the puck. So over here, I have what looks like the number 7 or a hockey stick that's upside down. And over here, hydrogen, there's our puck. All right, and so that's how I remember these ones. So we would write N2 gas and O2 gas and F2 gas. Well, how do I know they're a gas? Or how do I know it's a liquid? Or how do I know that it's a solid? And just a reminder that even though hydrogen is on the metal side, the left side of the periodic table, he does act like a non-metal, and that's why we're memorizing him for this. So what if I'm asked about the states of these guys? Well, the state states are listed here. So we're not concerned about the metallic solids. These are all the guys in here, the metals, but we're looking at the non-metals. So we can see the non-metallic solids. So boron is a solid, carbon is a solid, and those guys are monoatomic. There's only one atom there. But you'll notice that a lot of these non-metal elements are listed in blue, and that means they're gases. And so remember, it's N2 gas, O2 gas, F2 gas, Cl2 gas, and oh, what about this guy? Why is it pink? Well, like I said, bromine, Br2, he is a liquid, and so you have to pay attention to each of them with their states, as well as whether they are diatomic or monoatomic or polyatomic. So here's phosphorus. He's P4, likes to hang out with a posse of friends, and same for sulfur, S8 solid. That's a big gang of sulfurs, and they all work together to share electrons. That's why we call these covalent molecules or covalent bonds. Okay, so just a reminder of when you're naming, you have some prefixes that you will have to refer to. So again, you need to memorize these prefixes. 1 is mono, 2 is di, 3 is tri, etc. And as we learned in the last video, that was the one by Mr. DeWitt, that the rules for naming are we start out with the first element in the name. So here's our first element. We look him up, and his name is nitrogen. And so now we see there's a number 2 there, right? And so we said, well, what's the prefix for 2? So we write dinitrogen. And then the second element, well, the second element is O, and so we change it to the IDE ending. So it's not oxygen anymore, it's oxide. And then we have to add a prefix in front of the name. So we've got nitrogen, which becomes dinitrogen because of the 2. And then we have oxygen, which becomes an IDE ending. And then how many oxygens are there? Well, let's have a look. Oh, there's only one O. So we would write the prefix mono oxide. But wait a minute, that sounds goofy, doesn't it? So that's what we talked about. Well, actually, Mr. DeWitt talked about in the last video. He's like, no, you don't put the 2 O's together like that. You just use one of them. And so now you put the names together. So you've got dinitrogen monoxide, and that is the correct name for this compound, N2O. Okay, so that was just a short little video. And one more thing before I go is just to remind you that there is a special additional set of naming rules for any of the molecular compounds that have hydrogen in them, because hydrogen is special. Remember, it's on the left side with the metals, and so it gets its own rules for naming. So most of these are what I call the one-word wonders. And so these are in your data booklet, but honestly, you should make up flashcards on them to learn them and memorize them. You'll see that many of them have just one word, like sucrose, glucose, methane, right? And so that's why I call them the one-word wonders, is that many of them, instead of having the 2 words, because there's many different elements in some cases, they have just one word for their name. Okay, and so this in your notes guide is the table with the one-word wonders, but you also have a table in your data booklet. So here's the table in your data booklet, and it is on page 3. And so this is the table, and like I said, a lot of these one-word wonders are molecular elements that have hydrogen in them. So like here's a one word, ammonia, and here it has hydrogen. So it's a molecular compound because it has the non-metal nitrogen and the non-metal hydrogen. But we would not name that nitrogen trihydride. It has a special name, and the special name is ammonia. Okay, so all of these one-word guys, benzene, butane, ethane, ethanol, right? Here's a bunch of these ones that have hydrogen in the formula. So because they have hydrogen in the formula, they have a special set of naming rules, and you will need to look them up or memorize these so that you know the names when you see them on an assessment or a worksheet. Okay, so that's it. That's all. That's all I got for you today. That's just a little additional video to some of the other ones you've been watching on naming molecular compounds and being able to tell the difference between ionic and molecular. Okay, well, that's it. I'm signing off. We'll talk to you later. Bye-bye.